Welcome back everybody to another new video of friction. So this is going to be about 20 minutes lecture like that, and let's start with the chapter without wasting much of the time. So friction. So friction is divided into two parts: static friction and kinetic friction. So Fk we represent static friction and Fs we represent static friction and Fk we represent as kinetic friction. So basically in kinetic friction we will use a constant of friction, which is mu k multiplied by n will be constant. Okay, so for example, let's say a block is in a plane and it is moving 10 meter per second on this side. So when it moves on this side, so there will be a static friction acting to it. So according to the relative motion, friction will be to the opposite direction of the relative motion. Okay, so in this case it moves like this, so friction will act opposite in this direction. Fine. So in this value will be equal to mu k n. Similar to this, the same thing will be repeated here also. But in static friction is a self-adjusting force. So Fs max will be equal to mu s n, where mu s is the static friction coefficient and n is normal force. So basically it will be self-adjusting towards according to the scenario. For example, let's take a 10 kg block and let's apply a force F. Okay, when you apply a force F and the surface is having the coefficient 0.6, which is initially at rest. Now we need to calculate the Fs max value. So this is the coefficient multiplied by the mass into gravity, which is mg force, will actually be the normal force. So which will give the value 60 newton. So basically 60 newton will be the Fs maximum value. Okay, so nothing can't be, so static friction will not be more than static friction will not be applicable when the force is applied more than 60 newtons. So in this case F is applied. Okay, if F is 70 newton, let's say, the block starts moving and the friction which will be acting is kinetic friction, not static friction. Let's take 59.999 case. So in that case static friction will be acting because it is lesser than 60. I hope you understand. So now let's see a a table where it represents the acceleration with respect to the force applied. So this is the force applied, this is the acceleration, this is the frictional force. So basically I said it's self-adjusting force, which means the maximum value is this. Okay, for example, if you apply 20 newtons, which is lesser than 60 degrees, so static force will be applicable. So F won't be mu s n. No, it is wrong. Instead, it will be 20 newton. It can be up to 60 newton, not above that. Fine. So the next thing is, yeah, the graph. Okay, you can see like 10 newton, 20 newton, 30 newton, 50 newton, 59.9 newton are applied and no acceleration because they are gonna be with the static friction, so it won't have movements. So similarly you can see it is self-adjusting the force as this and this are same. Okay, but finally the moment you apply above 60 Newton, which is 60.1, it goes for uh, kinetic friction, which gives an acceleration of 1.01, and the friction constant, which is 50. Fine. So this is the graph for the above table. So basically, until the static friction maximum completes, so the y-axis will be same as x-axis. Okay, that will be static friction. So the moment it gets completed, you can see from here, it gets reduced. It's 59.9, it gets reduced to 50. So that gives a slope here and becomes constant after a certain time. Okay, so generally coefficient of static friction will be greater than coefficient of kinetic friction. Okay, so yeah, let's see some couple of questions. Like this chapter is mostly based on questions. So basically there is a 10 kg block and 20 newtons is applied, and in all the cases, this case, in all the question cases, we will take static coefficient of static friction as 0.6 and coefficient of kinetic friction as 0.5. So we need to first calculate the static friction maximum value, which comes out to be multiplied by 100, which is the normal force, because mg is equal to 100 Newton. So normal force will also be equal to 100 Newton. So when you multiply with 100, you will get 60 Newton. So any force below 60 Newton, the static force will be applicable. So 20 Newton comes below 60 Newton, which means static friction will be applied in this direction, which is equal to 20 Newton. Okay, it is above in the second case it is above 16 Newton, which is 61 in this case. So in this case we use kinetic friction, which is multiplied by normal force, and 50 Newton will be applied in this direction. Okay, the net force will be what? So here 50, right? So 11 newtons, 11 Newton will be the net force. So simply the acceleration F is equal to ma. We found that F net is equal to 11 multiplied by 10 multiplied by acceleration. So 11 by 10 will be the acceleration. Okay, so yeah, this question is also same. Like here you can take the net force applied, which is 80 Newton, and then calculate the value, which is of course it will execute kinetic friction. You can also find the acceleration of it. So similar to this is the same type of question. So we can actually see that and get the uh, idea of it. So what about this question? This question is also like a similar type of question where pulleys are involved. So basically a 10 kg block will execute mg force of 100 Newton, right? So when we take gravitational constant as 10, it will execute 100 Newton. So here tension force will be applying, here tension force will be applying, and here they have said that mu, right? Mu is equal to 0. So when mu is equal to 0, I can directly tell 100 minus no force are applied at the top and by the total weight, which is 20. So you will get 5 as the answer. Okay, in this case, if the coefficient, if this surface, instead of a smooth surface or a rough surface is added, the case will be changed, right? So acceleration, when it will be given 100 newtons this side, which means it is above the 60 Newton case. So whenever it's 16 above 16 Newton, so it will act friction, kinetic friction of 50 newtons on this side. So the net force on this side will be 50 Newton. So you can find the acceleration and all. Fine. So the next case is also pretty similar, but in this case we are giving 70 Newton force on this side. So basically when 70 newtons is given on this side and 100 newton is given this side. So it comes out to be 30 newtons on this side as the F net, right? So when it is given 30 newton, it will be under the condition of static friction. So when it is static friction, 30 newton will be applied on, sorry, 30 newton will be applied on the opposite direction of the relative motion. Fine. So what about this? So this is same type of problem. I think there shouldn't be much confusion on this. So yeah. So basically 10 Newton is applied, 120 Newton is applied here, right? So 20 Newton will be applied on net on this side, 20 Newton. So which comes out to be a condition of static friction, and 20 Newton will be applied on the opposite direction of the relative motion, and simply we can say that the magnitude of the static friction is going to be 20 Newton. So similar to this, here 100 Newton force will be applied, here 120 Newton force will be applied. So simply here 20 Newton force will be applied. So the relative motion will be of course on this side, but in this case static friction value is, since it is very high, so it won't have any acceleration, so it will be exerting a force 20 Newton. And then like finding the component and doing the problems is also should be an easier case, as you have already learned Newton's laws of motion. So if there is a block of 10 kg and a is acting force acting on it is 100 Newton, and it has an angle with the x-axis 37 degrees. Okay, so mu is equal to 0.5. So you can take two components, which is f cos theta, which is 37, f sin 37. So this will be mg, and here will be normal force. So normal force will be simply equal to f, sorry wait, normal force plus f sin 30 will be equal to mg, right? So n is equal to mg plus, sorry, minus f sin 37. This is 37. So simply you can do this and get the value of normal force and then apply the value it in the equation of this. Fine, you'll find the, since you find the value as 20 here, and as this component gives 80 Newton value, which means 80 Newton force is applied on the horizontal direction opposite to the friction force. So this doesn't comes under the case of static friction and goes for the kinetic friction, and it will have an acceleration of 3 meter per second square. Okay, the next question is also of the same type. So we need to find the m dash minimum value so that the m can move. So basically you need to draw the free body diagram and the forces acting on it. So since it needs to move, it needs to move, it needs to overcome the static friction's maximum value so that it will have some movement. So in this case the static friction's maximum value should be overcome by t cos theta for sure. So this is fs max equation, and t cos theta should be more than fs max. Okay, or equal to. Okay, so yeah. So next we have a good question. In a figure shown in a mass m and a block of mass m is in equilibrium, the string is light and pulley P does not offer any friction, and coefficient of friction between the pole m is mu. The friction offer force offered by the pole on m is. So basically, so normal forces on this direction, you can see all the forces which are acting, which have been already marked. So in this case fs mu n. Okay, mu n, and Fs is equal to mu multiplied by m, mg, right? So this will be the force which is transferring here. So normal force will be equal to mg for sure. So in that case you can put the mg on the place of normal force, so you will get a static friction of mu multiplied by mg, which is absolutely wrong, because it is at the equilibrium. Okay, they've mentioned it. So when it is at the equilibrium and the force acting on this direction we know is frictional force, and here mg force is acting, which means at the same component only two forces exist, so they both should be equal. Rather than doing these all stuffs, they both should be equal, and Fs is equal to mg will be the correct answer to this question. So let's have another question, like so we need to define the time taken by the bead to reach B from A. So basically a bead is dropped from the height h, and they are asking the find the time taken by the bead to reach from A to B. So basically there are a concept called pseudo force, you must have studied in the previous chapter. If you have studied that, so if we make an observer sit here, you will find ma is acting on this side, and so basically here kinetic friction will be acting because it is in motion, and downwards mg will be acting. So normal force will be acting on this side, so that I can tell that normal force is equal to ma. Okay, because this side it is in equilibrium. Okay, so normal force will be equal to ma. So yeah, do that and get the answer. And after getting this value, you will get h, you can apply in kinematics formula and get it. So a dash y, don't confuse it, it's just acceleration in y direction. So mg minus f by the mass will give you acceleration. I hope you understand these things fine. So next is wedge related problems. So wedge related problems, I think the component division is the main thing. Until if you do that, rest of the things are pretty simple. So basically a 10 kg block is in the acceleration like this, and mu is equal to 0. You can just calculate the acceleration. So take the components in the, so this will be basically 100 newton, and this will be basically 60 newton. So 100 minus 60 by 2 to 20, okay, which is the mass, total mass of two bodies. This is a normal case. If the surface is have the coefficient 0.5, you just multiply 0.5 multiplied by the normal force. Normal force is simply mg cos 37. So in that case mg cos, in this case mg cos 37 is 80. So you can get the friction value which will be acting on this side as 40 newton. Yeah, try to do this at home. This is easy question. Fine. The next thing is a question. Let's say a block m is placed in the inclined surface and it is gonna slide with speed u v, let's say, and acceleration is also in this direction. We are set to find the acceleration. So basically mg sin theta is in this direction. So since acceleration and velocity is also in this direction, so f will be acting on this direction, which is mu mg cos theta, because normal force will mg be mg cos theta, right? So mu multiplied by normal force, which is mu mg cos theta. So yeah, so since the acceleration is on this side, so mg sin theta minus mu mg cos theta will be becoming equal to a1. So in another opposite case, when it is climbing up and it becomes rest here, which means acceleration is on this direction and velocity is on this direction. In the same case, since the velocity is in this direction, this will be moving in this direction, so friction will be this direction. So mg sin theta plus f. So g sin theta minus mu g cos theta will be coming, sorry, plus mu g cos theta will be coming. This should be plus because both are acting in the same direction. The questions can be formed like acceleration we need to find, and then let's say velocity is given, and then what distance it may stop in the inclined plane they can ask, or what time it will stop. The questions may be formed like that. So I think, yeah. So this type of question, m block is there, and friction coefficient is mu, and friction is acting for sure. So what is the minimum force minimum to slide up? So force minimum should be basically, let's say mg sin theta is acting on this direction and friction force is also acting on this direction. So mg sin theta plus mu mg cos theta will be the minimum force which is required to slide up. So similarly, another question, what is the minimum force to prevent slipping down? So basically friction force is acting on this side and mg sin theta is acting on this side, which means f plus f will be equal to mg sin theta. Okay, so what will be the minimum force required to prevent the slipping? So f will be equal to mg sin theta minus f, small f. Fine. So in this case f is simply mu mg cos theta. Next thing we are going to study is angle of repose. So angle of repose is nothing but, let's say there is a block here, and this have some friction, let's say mu is equal to 0.1. so the more the angle increases, the block moves at certain point. Okay, so the angle at which the block gets down, slides, is basically called the angle of repose. So basically in this case mg sin theta and static friction force are acting, so just it moves at a certain point, and when the frictional force is just above the maximum static friction, the block will start moving, right? So basically when they are equal, let's say this force is applied and this force is applied, so whenever the moment they are equal, it will start in the next moment itself, right? Start moving in the next moment itself. So I can equate it both, and yeah, the mg will get cancelled, and this goes on this side and become tan theta. Mu is equal to tan theta. If you take tan on other side, you will get tan theta is equal to tan inverse mu s. Okay, this is the formula of angle of repose. And what about the let's take a normal force like this, and a frictional force like this. So in this case, if they ask you to find the f net of contact forces, f and mg will not be a contact force, but this will be, these two will be contact force. So f net will be the vector product of both of these. So you can find in that way. You can also find the angle of repose for this, right? So which is basically mu naught mu s. Okay, and then we will be looking on the things about two block systems. So two block system, basically there are two blocks, and the plane will have no friction, and the friction between these two blocks is going to be 0. Mu is going to be, frictional coefficient will be 0.4. So in that case, if we draw the free body diagram of both the blocks, it will be like this. So friction will be acting, so acceleration will be also acting in this direction. So frictional force will be acting in this direction for the second block due to the first block. So and then the force will be acting in this block. Okay, so for these two blocks to move together, without slipping, how much acceleration is common maximum acceleration we can apply? So that's the question. So let's take the maximum force which can be applied. So when maximum, at the moment when the maximum, till the maximum friction, it will be moving in the same acceleration. So basically F by mass of this will be basically equal to the acceleration, and that will be equal when we take the, when we want the maximum equation. So we will apply this Fs max divided by mass. So mass in this case is 10 kg, we apply 10 kg. Fs maximum will be 40 newton, so 40 newton will be applied, and the answer comes out to be 4 newton. And this will be the acceleration for the below thing also, below block also. So that will be also, so the common acceleration maximum will be equal to 4 meter per second square. Okay, so I can tell that this entire body is gonna travel at acceleration 4 meter per second square. In that case, the both won't get slipped away, and the force maximum will be simply equal to the total mass multiplied by the acceleration, which gives out to be 120 newton, and Fs max will be 120 newton. Both the questions are answered now. So basically when the force is equal to or lesser than, sorry, greater lesser than 120 newton, there won't be any slipping. So acceleration of a1 will be equal to a2. So whenever the force is greater than 120, acceleration of a1 will not be equal to acceleration of a2, and slipping will happen. Okay, so in the other question, we have applied 90 newtons in the same question. Since because the maximum force should be applied as 120 newton, since it is lesser than 120 newton, it won't undergo slipping. So when it doesn't undergo slipping, we can find the acceleration, common acceleration. Okay, so 94 newton is applied, so 90 newton is equal to the total mass multiplied by the acceleration, and acceleration comes out to be 3 meter per second square. If you are asked to find the frictional force of each and a block, each block, so basically it is of 10 kilograms, right? So frictional force will be applied on this direction, which will be equal to 10 multiplied by the acceleration. So acceleration is 3, and 30 newton force will be applied. So in the 20 kg block, so here 90 newton is applied, and friction is applied in this direction. So um, F 90 minus F will be equal to MA, right? So apply this here, and you will get friction value is equal to 30. Yeah, this is the last problem. And now the same thing, let's say 200 newton is of force is applied, so which is definitely greater than 120 newton, which means when this is applied 200 newton, the above block will undergo slipping. So the above block will, since it undergoes slipping, it will have some velocity in some direction, so it will undergo kinetic friction. So the maximum acceleration this block can possess, we have seen it earlier, which is 4 meter per second square. But for the second block, since 200 newtons is applied on this direction and 40 newtons is applied on this direction, so the net force will be divided by the mass, and we will get 8. So with that, we will be completing this friction part. So yeah, thank you for watching. Please subscribe to my channel.